Okay, we're going to talk here about extrema on both open and closed intervals. So just to get things started, taking a look at this picture, if we look at this function, the first derivative at this point is 0, and this would be considered a local, also called a relative maximum. Maxima and minima are both types of extrema. This is a local or relative minimum, and the derivative there is undefined. Here we have a local maximum, derivative is 0. We would say that this is an absolute minimum because it's the lowest point on the entire interval, except there's no point there. And so this particular function has no absolute minimum. However, it does have an absolute maximum, which occurs where this relative maximum is as well. In this function, we have local min here, and derivative is 0. No local max because there's no point there. This is an absolute minimum, so it's at an endpoint, and there is no absolute maximum because this goes off to infinity. This function, derivative is undefined, so local min. Derivative is 0. A local max, derivative is 0. A local min over here. This is also an absolute minimum because it's the lowest y value on the entire interval. This is an absolute maximum because the highest y value on the entire interval. Absolute can also become global. So this is the global minimum, the global maximum. So to summarize a few results, extrema, which are minima or maxima, come in two types. There's the relative, which is just in some small interval, and there's the absolute for the entire graph. And relative and local basically mean the same thing. Absolute and global, same thing. Now, find an absolute extrema. But first find the critical numbers, and critical numbers are where the derivative is 0 or undefined, which are all those places that we were looking at in the last few sketches. So derivative is 0 or undefined are critical numbers. Make a table of values using all the critical numbers and the endpoints, because as we saw, you might have an absolute minimum max at an endpoint. Your highest value is the absolute max, that's the highest y value. Your lowest y value is the absolute min. So we make that table of values, critical numbers and endpoints, and we find out the y values. So the location of an extremum is an x value. The value of it is a y value. Now there's a few things to be aware of, and that is that all the local mins and maxes are critical numbers. However, a critical number does not guarantee a local min or max. Critical numbers are candidates. They're not guaranteed locations. For instance, here we have a 0 derivative, and we went from actually increasing, so positive derivative, to 0 to increasing. Well, as we'll see with the first derivative test in a couple of classes, the derivative didn't change sign, and because of that, this is not a local max or a min. And so just because it's a critical number does not guarantee it is a relative max or min. Okay, over here, one other thing I wanted to point out was this is a higher y value than this one. However, this is a local min and this is a local max. So it can be difficult to tell until we get into things such as the first derivative test in a couple sections exactly if it's a min or a max. All you can see from y values is that it's higher than this one. It's harder to tell that this is actually a local min, this is a local max. Okay, over here we have a parabola. Domain is all real numbers, and we're trying to find local mins and maxes. And there's an absolute minimum. There is no absolute maximum because it goes up to infinity. Here we have the closed interval 0 to 2. So we've got absolute minimum and absolute max. Now we're going to open up the left side. So there's no absolute minimum and there's no point there. You don't pick the one infinitesimally close to the endpoint. But there is an absolute max. And if we open up both sides, we have no absolute min or max. And so I'm going to actually skip through this because we already discussed this actually. And let's take a look at an example. Okay, critical points are always maximum minimum, are not always maximum minimum values. They don't guarantee it. Okay, so x to the 2/3, we want to find a max and minimum values on the interval -2 to 3. And so we find critical numbers. So you find the first derivative, set it equal to 0, and see where it's undefined. It's never going to equal 0, but it will be undefined when x is 0. And so we have to check x equals 0 and -2 and 3, that is the endpoints. And so we plug them into the original function. This has to do with finding whether they're actually maxes or mins. We'll talk about it in a couple sections from now. But basically, we're going to plug in 0 and the two endpoints, and what we discover is that our absolute max occurs at x equals 3 with this value. Our absolute min occurs at x equals 0 with the value of 0. So there we are, absolute min, absolute max. And there's a little graph of it over that appropriate interval. So here are some steps. And remember, they're not always extreme.